Okay, I'm going to do all three of these problems, but I want to point out that the tools for using these problems are these two equations. So this one has a constant, which is right here. It's the speed of light, or speed of any electromagnetic radiation, which is 3.00 times 10 to the 8th meters per second. And this equation here has another constant called Planck's constant in it, and that's the 6.626 times 10 to the negative 34th joules times seconds. Okay, so these are constants that you'll plug in. So bottom line is, with this equation, it shows you that the relationship between wavelength and frequency. If wavelength goes up, then frequency must go down since they're both equal to a constant, this right here. This equation right here gives you the energy if you know the frequency, and vice versa. And Planck's constant is what makes them equal to each other. Okay, so first one, what we're looking at is we know wavelength. And they ask for frequency, which means we must be using, I'm going to change my color here. We're using this equation, but we're going to rearrange it because we need to solve for wavelength. So this is what we're actually using. Okay, and another thing is, if you're worried about your algebra and whether you rearrange things, that's why it's also really important to plug in your units too. So here's the constant, times 10 to the 8th meters per second. And then they gave you frequency right here of 8.3 times 10 to the formatting got a little weird. That's 15th in hertz. Hertz is a frequency, which is waves per second, but really we don't have a unit for waves, so it's just 1 over seconds. So hertz, when you're dealing with units, is really just 1 over seconds. Now I know I did my algebra right because these cancel and it leaves me in meters, and that makes sense for a wavelength unit. When you do your number crunching, you're going to get 0.036 times, that's by the way, that would be by taking the 0.36 by taking 3 and dividing by 8.3. And then I'm going to subtract my exponents. So I'm going to do 8 minus 15. That gives me negative 10 to the negative 7 meters. And then I'm going to turn this into proper scientific notation, which is 3.6 times 10 to the negative 8th meters. That is the wavelength. So now we are done with number one. The second equation asks you for frequency. So we're going to take this same equation, but we're going to rearrange it so that we're solving for frequency now instead. Okay, so I'm going to set this whole thing equal to frequency. Frequency equals, same constant on top, 3.0 times 10 to the 8th meters per second. And they give you a wavelength of 4.2 times 10 to the negative 5th meters. Meters cancel, and it leaves me in 1 over s, which is the waves per second, or hertz, so that's a frequency unit. Do my number crunching. When I take 3 and I divide by 4.2, I get 0.71. And when I take my exponents here, 8 minus a negative 5, I get 13. 1 over s, and then when I convert that into proper scientific notation, 7.1 times 10 to the 12th, 1 over s. That's the answer. So we are now done with the second problem. And then the last problem says, what's the energy of the photon of each above? Now, I'm just going to do this one. Okay, so I know my frequency. My frequency is right here, and if I know this frequency, I know this. And I have this constant, so I know this. So all I have to do now to find my energy is plug those two values in. So I've got 6.626 times 10 to the negative 34, and that's joules times seconds. And then this value right here, 7.1. Whoa, that's kind of messy. 7.1 times 10 to the 12th, 1 over s. The seconds cancel with the 1 over seconds, and I'm in joules, which is an energy unit, so that makes sense. When I do my number crunching for that, when I do this value times this value, times this value right here, I get 47. And then I add my negative 34 and 12 together, and I get negative 22 1 over s. And all I have to do is just convert that into proper scientific notation. And since this number here got smaller, I'm going to make negative 22 bigger by turning in negative 21 1 over s. That is my answer. And that's how to do those problems, all three of them.